Okay, my name is Professor Terry Clark, and welcome to our go-to training on graphing and word problems. So we're going to get started with the graphing, then we're going to take maybe about a 5-minute break, and then we'll come back and wrap it up with the word problems. And then after that, any remaining time we'll use for question and answer session about the project or Alex. Okay, so graphing. A little bit about the history of graphing. Graphing's been around a while. The Egyptians, the Romans, and the Greeks, they used it for surveying and map making. Okay, the rectangular coordinate system, as we know it, or the Cartesian coordinate system, was first discovered by the mathematician by the name of Rene Descartes around the 17th century. Okay, it didn't show up into high school books until around the 1900s. So it's not always been something that we've taught inside the classroom. Uh, Two important things that graphing is used for today is navigation and modern warfare. Okay, when we're looking at our graphing system, a rectangular coordinate system, we have a vertical axis and a horizontal axis. The horizontal axis has all of our independent variables on it. The vertical axis has all of our dependent variables on it. Okay. Dependent variables are the x values and the independent variables are the x values and the dependent variables are the y values. Here we're going to use a table, a function table. Now, tables and graphs, okay, they're all summary devices. They're devices that we use to summarize information. So the information that we're going to need for the independent variables and the dependent variables can be summarized in a table. Okay, so the way we do that is we simply put in the value for x and then we solve for y. So if we put in 1 for x, then 2 times 1 is 2, and then 5 minus 2 is 3. So that means y equals 3. We'll do the same thing for 2. When x is 2, we put in that value for x. And 2 times 2 is 4, and then 5 minus 4 is 1. And then we do the same thing for 5. When x is 5, we substitute the x for the 5. We do the math. 2 times 5 is 10, and then 5 minus 10 is negative 5. So our values for x and y in our first order pair are 1 and 3. Second order pair is 2 and 1, and then our third order pair is 5 and negative 5. Okay, so we'll just simply take this value and that value, and then we'll put them together as 1 and 3. Okay, so this is how we notate a pair. Okay, and basically what we're saying is that when x is 1, y is 3. And then we'll do the same thing for when x is 2. Then we'll say y is 1. And so when you see parentheses like this right here, this denotes a pair. And then we got 5 and negative 5. Okay, so this is how we recognize the pairs. Now we could also leave them in the table because the table has the pairs summarized as well. Okay, so those are our order pairs. And here we have y equals 27 minus 3x is our next function. Once again, we'll use a table to summarize our order pairs. Okay, in this case, we're going to use 3, 5, and 6. For our x values, we can choose whatever values we want to choose. Most of the times, people choose smaller numbers like 0, 1, and 2. It just makes the math easier, unless we're working with fractions. And then I'll show you a little trick to make the fractions easier as well when we see one. Okay, so we put in 3 for x, and then that'll give us what y is. we put in 5 for x, and that'll give us what y is. And we put in 6 for x, and then that'll give us what y is as well. Okay. Now here we have a graph of test and average points. Okay, the test numbers 1, 2, 3, 4, 5 are independent variables. Those are your x values, and your average scores are your y values or your dependent variables. And we can also see that by the fact that the average scores are on our y-axis, and our test numbers are on our x-axis. Okay, so if we look at it, we say, okay, if we want to look at this one right here, we would simply go where x is 3, and then we can see right here y is about right here, about 90, and that's where 96 is. And so if we went here, and then we went straight up, we can see when x is 3, y will be 96, because it's slightly under 100. Okay, so here's some more practice for plotting ordered pairs. Okay, so our first ordered pair is 1 and 2. And of course we can see when x is 1, and it would be 1 right here. Okay, y is 2. And when x is 3, y is 5, and of course this 1, 2, and then this will make 3 right here, and that's going to make 5 in here. And of course if we went over for 5 and up for 3, we can see that the ordered pair of 3 and 5 intersect at that B value, or that point right there for B. And then we have -2 and 3, and then -3 and -4, and then 2 and -1, and then 0 and 5, and then finally 10 and 0. Okay, and at 10 and 0, y is of course 0, so that's why it's right on the axis. Anytime you see values like the last two, okay, like this right here is what's called an x-intercept. So that's going to be an x-intercept. X-intercepts are where the y value is always 0. So that's your x-intercept. And then this one is going to be your y-intercept. So that would be your y-intercept right there, the y one. Because x is 0. So our intercepts are at our 0 values for the other ordered pair. So we're looking for our y-intercept, x will be 0. And we're looking for our x-intercept, y will be 0. And our intercept will always be on our x and y axis. Okay, notice right here how it's right on the x-axis. And then the other one for your y-intercepts right there at 0 and 5 is right on your y-axis. Okay, so sometimes we'll be asked to graph an equation. We have one here, y equals x. We're going to first start with our table, and then we'll plug in values for x and y. What we're saying is that x and y are the same values, so if x is 0, y will be 0. If x is 5, y will be 5. If x is -3, y will be -3, because we're saying they equal the same value. And then we simply have to plot these points. So these are going to be our order pairs, 0, 0, 1, 1, and 2, 2. And we draw our line. Okay, now as we draw our line, if we were to look, across this graph, we'll see that, the points are pretty consistent. Okay. Okay, our next problem, we're going to be asked the graph. We're saying that x and y are the opposite of each other. So if x is a positive 3, y is a negative 3. If x is 2, y is negative 2. If x is negative 5, y is positive 5. Okay, they're simply the opposite of each other. That's what that negative means. If they were the same, it would be y and x equals the same thing. Okay, so we'll plot those points. Okay, let's go back and look at it closely. Okay, so when we plot the points, we can see our values for x and y on our graph. It takes 3 points to graph. Okay, you've got 2 points that you need, and then another you have a checkpoint. Okay, so typically that's what we do. We have a point of origin, point of destination, and a checkpoint. And so we just connect the dots, and that's how we graph. All right, the bare minimum you could get away with 2 points. Okay, but to be safe, it's always best to use 3. Oh, that's going the wrong way. Okay, the slope is something that we'll use to better understand a graph. It's going to be the rise and fall of the graph as we travel from the left to the right side. There are 4 types of slopes. There's a positive slope, there's a negative slope, there's a 0 slope, and then there's an undefined slope. Okay, the slope is simply the rise over the run, or the change in the y value over the change in the x value. Okay, so here we have a graph, and we're saying that the slope in this case is going to be 4. Okay, it's rising 4. Oh, no, it's going to be 2. It's rising 4 and it's running 2. So it's rising 4. Now we say it's rising 4. We're meaning from here to here it's going up 4. Okay, because that's from 0 and that's actually 4 right there. And then this is 1. And then that's 3. Okay, so it's rising 4 and it's going over 3. Okay, so it's rising 4 and running 2. And so we'll put that as 4 over 2. And then we'll divide. 4 divided by 2 is 2. So our slope is 2. Okay, here's a positive slope. It's going up. Negative slope is going down. A 0 slope is a flat line. It's neither going up or down, staying the same. And a vertical or undefined slope is simply, a vertical line. So it's going vertical and it's undefined. Okay, so here's an equation here, and if we're going to graph it, first thing we're going to do is summarize the ordered pairs in a table. We're going to use the values 0, 1, and 2. And we'll simply plug those in for x, do the math. 0 times 3, 1 times 3, and 2 times 3. And then that'll give us our ordered pairs. And from there, we're ready to grab our points. Okay, and of course we can see in order to graph, we always started by point of origin. So here we are at 2 and 6. So we simply from our point of origin go over 2 and then go up 6. Okay, here. Now this is the one where we were talking about earlier where I said if we're working with fractions, you don't want to use 0, 1, and 2, even though they're simple numbers. You want to use a multiple of the denominator of the fraction. So that 1/3 has a 3 in it. Okay, so what we want to do is use a multiple of 3 because what we're doing is we're looking at figuring out a way to cross cancel out this 3 here. So the values we're going to use are probably going to be 0, 3, and 6 or 3, 6, and 9. Okay, and so when we put those numbers in there, then they end up cross canceling out. Okay, because if we have 1/3 times 3, the 3's cancel out and we're left with 1. Okay, and that's what we end up doing here. This 3 and that 3 cancel out and we're left with 1. Here the 3's cancel out and we're left with 2 here. And then 2 times 1 is 2. Okay, so from there we simply bring our ordered pairs together and then we plot our points. 0 and 0, 3 and 1, and then 6 and 2. And then we connect our lines. Okay, the larger the absolute value of the slope, the more vertical the line. The smaller the absolute value of the slope, the more horizontal the line. Okay, so that one right there has a larger absolute value of 3. So when you see 3, you see how steep that line is. Versus 1/3, that line is almost flat because it's closer to 0. So when we talk about absolute value, we're talking about how close the number is to 0. The closer it is to 0, then the more flat the line will be. The further away from 0, the more steep the line will be, either vertically, either up or down. Okay, another number we'll come across is the y-intercept, and we talked about that briefly already. That's where your x value is 0. Okay, here is a problem written in slope-intercept form. That means that your y value or your y-intercept is given to you as b, and the slope is m. Okay, so here's a problem here. In this problem, we'll simply choose 3 independent variables, 0, 1, and 2 for x, and then we'll solve for y by putting the x values into the equation and solving for y. And now we're ready. 0, 2, 1, and 3, and 2 and 4. From there, we plot the points. Okay, and then we connect the dots. And of course, our slope is going to be 1 because it's 1 to 1. Every time x increases by 1, y is going to increase by 1. And here's another problem for us. Because our denominator is 2 here, we'll be using multiples of 2. So we'll use 0, 2, and 4. Okay, and that's to cancel the 2's out when we cross cancel when we're multiplying with the fractions. So 0, 2, and 4. I mean, if you use 0, 1, and 2, you're going to have a lot of fractions for your y values. And so we want to use 0, 2, and 4. So when we do the math, 1/2 times 0 is 0. 0 plus 1 is 1. 1/2 times 2 is -1. And -1 plus 1 is 0. And then -1/2 times 4 is -2. And -2 plus 1 is -1. Okay. Then we'll simply list our order pairs. And our next step is to plot our points. And our last step is to find our slope. Okay, here's another problem to graph. Here we're going to simply use our table. We'll put in our values for x. It can be 0, 1, and 2 in this case. And then we do the math to find y. Okay, put in a value for x and then do the math to find y. Okay, and so we have 0, 5, 1, and 2, 2 and -1. And from there, we'll plot our points. And find our slope. Now, our slope can easily be found in this problem. The slope is -3. The slope can be seen right here. This is slope intercept form. And it can also be seen right here in the graph. Okay, so we can see where we went down 3 here. And we went over 1 here. So we ended up with -3 over 1, which is -3. Okay. So now the only time we can find the slope in the equation is when the equation is written in slope-intercept form. Like this equation is written in slope-intercept form. Okay, and here we have an example of the formula. Okay, we just see how the formula is being derived from the graph here for your x value. And then for your y value. Okay. Let's simply look at the change in x over the change in y. Okay, so here they're asking us to find the slope. You know, we can clearly find the slope 2 ways. We can use the formula and just say 7 minus 4 is 3, and 8 minus 1 is 7. Okay, and then of course, let me go back. Right here we have 3 and 7, like that. Now with horizontal lines and vertical lines, okay, when we graph those, they'll always be y equals some number for the horizontal, and your vertical will always be x equals some number. So if we have x equals 7, we don't really have to plot any points. That's just going to be a vertical line crossing your x-axis at 7. Okay, here this one's going to cross at 4. Okay, and so we can see that here the y is crossing at 3, and here the x is crossing at 4. Okay, so we can see when x equals 4, it's going to cross your x-axis at 4, and y equals 3 is going to cross your y-axis at 3. Okay, so here we have y equals 4, So that's going to cross 4 is right here. Okay, so that's going to cross your y-axis at 4 there. And then, of course, the slope will be 0 because it's a flat line. And x equals 4. It's going to be right here at 4. And the slope will be undefined. Okay, slope-intercept form. What I want to do is copy this video. I'll let you guys look at this video on your own. Copy it, shut it down. I'll provide it to you in the chat area. Where's the chat box at? For some reason it doesn't want to pull up. Where's the chat at? Here we go. All right, here we go. So we copy it. Okay, so there's the link to it. Okay, so I mean, you guys can watch it on your own leisure time. All right, here's the formula: y equals mx plus b. The m is your slope and the b is your y-intercept. And the y-intercept is where the graph crosses your y-axis. So when we're asked to find the slope in the y-intercept in 3x plus 5, the slope is going to be 3, and the y-intercept is going to be 5. In the equation negative 1/6 x plus 3, your slope is negative 1/6, and your y-intercept is 3. In the equation 7x minus 4, your slope is 7, and your y-intercept is negative 4. Okay, so when we graph using that y equals mx plus b, our first point is going to be 0, 4. Okay, and then our next point, we'll simply go over 3 and up 2. So we'll simply, for our next point, we'll use the slope here. We'll use this value right here. And that tells us that we simply go over 3 from here, which will stop us right here because 3 is right here on your x-axis. And then we'll go up 2. So that means we're going to go from 4 to 6. So it's going to bring us right here because that's up 2. Okay. And from there, we can just simply connect our lines. And that's our graph. Here's another problem. We have negative 3x plus 5. So our y-intercept is going to be 5. And our slope will be negative 3 over 1. So we'll start at 0 and 5 on our graph. And then we'll go down 3 and over 1. And over 1. And now we have our next point. And so from here, we'll simply connect the lines, or connect the dots, and that'll form a straight line. Here's another example. In this case, our y-intercept will be negative 2, and the slope will be negative 1. And so from negative 2, we're going to go down 1 and over 1, down 1 and 1 to the right. And now we're ready to connect the dots. Changing to slope-intercept form, here we have an equation, and we want to rewrite it to put it in slope-intercept form. So what we're going to do is solve for y. That means that we're going to add 8x to both sides. Then we're going to divide 2 from both sides because we're trying to get the y by itself. Only way we can do that is by doing the opposite of whatever the operations are doing to the y value. So in this case, negative 8x is adding and 2 is multiplying. So we do the opposite of adding. I'm sorry, it's not adding, it's subtracting because that's a negative 8x. And the 2 is multiplying, so we do the opposite of multiplying by 2, which is to divide 2. Okay, and so finally, here's our answer. Y equals negative 8 plus 4x. So we can simply say y equals 4x minus 8. Negative and subtract mean the same thing. Okay, so here we have another problem. So we're going to add 13x to both sides to get rid of the negative 13x or the subtraction of 13x. Then we're going to divide both sides by 17 to get rid of the multiplication of 17. And of course, our final answer, we can just move it to 13 over 17x plus 9 over 17. Okay, now these problems right here are very important because these are going to be the types of problems you're going to see in Project 2. Okay, so they're very important. They're going to help us with our break-even points. You'll even be asked to put a graph in the project. So you really need to pay close attention to examples of systems of linear equations. Here's a problem right here. It says the first order was 13 bushes at 4 trees and it totaled $487. The second order was for 6 bushes and 2 trees and it totaled $232. Okay, what were the costs of 1 bush and 1 tree? Okay, now the system in this case right here, I'm going to go ahead and lay out the equation for you. This one right here is going to be one equation right here. We can see there are 2 separate problems, 2 different situations that need to be described. That's going to be one. And the other one is going to be right here. Okay. So in the first one, we've got 13 bushes. So we can say the bushes can be X plus 4 trees, which will be Y. And that'll total 487. Now obviously the X and Y in this case are money because you take the 4 trees and multiply it by the money that it costs. You take the 13 bushes and multiply it by the money it costs. In the second problem, we're going to have 6 X's. And we're going to have 2 trees, 2Y. And that's going to equal 232. Okay, so we'll be able to solve this problem 3 different ways. We'll be able to use a graph to solve it. We can graph the 13x plus 4y equals 487. And we can graph the 6x plus 2y equals 232. So we can graph them and solve it that way by finding the point that they intersect. That would be your solution. Or we can use the addition method or the substitution method. And we're going to learn about both of those in a second. So those are the 3 ways we can find our solution here. Okay, now here's an example here of graphing a system of linear equations. We've got y equals 3x minus 9 and y equals 2x minus 4. Okay, the solution is going to be right here where they intersect. Okay, and so that's going to be, the solution is going to be 5 and 6. We ought to pair 5 and 6. Okay, and so that'll work for both of those equations. it'll satisfy this one and it'll satisfy that one. Okay, so the first method we're going to learn is the elimination method. Okay, the elimination method works by adding the equations together and eliminating one of the variables. So in this case, we're going to eliminate the y, because if we add a positive 1y and a negative 1y together, they'll eliminate. So now we add the x and the x together, and that gives us 2x. And then we add the 5 and 1 together, and that gives us 6. From here, we'll divide both sides by 2, and x will equal 3. Okay, so we eliminated one of the variables by adding the equations together. Okay, and we add everything together, not just the things we're trying to eliminate. To solve for y, we simply plug in 3 for x on one of the equations. Okay, we could plug it into the first one. 3 plus y equals 5. And of course, 3 plus 2 equals 5. And we can always double check our work for the second one as well. 3 minus 2 equals 1. On this one, we can't just add them together because we need for one to be the opposite of the other one. Okay, so in this case, the top one is going to get multiplied by a negative 1. And then that's going to give us, I'm sorry, in this problem, we multiplied the bottom one by negative 1. Okay, and so that gave us, we actually ended up multiplying this one right here by a negative 1 down here. And everything gets multiplied by negative 1. So the 2x multiplied by negative 1, the negative 3 multiplied by negative 1, and then the positive 3 multiplied by negative 1. And that ended up giving us this brand new equation down here. From here, the y's will cancel out. 5x minus 2x is 3x, and 12 minus 3 is 9. From here, we'll divide both sides by 3. X equals 3. So we'll plug those values in. For the top one, we can just say 5 times 3. And then we'll solve for y. We subtract 15 from both sides. And then we'll divide both sides by negative 3. So y equals 1. And then we can check our work by plugging in 3 for x and 1 for y in both equations. On the left side and the right side must equal each other in order for it to be a solution for an equation. Here's another example. Okay, here we're going to multiply the entire top by 2. Okay, and the reason why is so we can get a negative 4y. And so we multiply by 2, this is what we'll come up with. 14x minus 4y equals 4. Okay, so these two can be combined together at this point. Okay, so that gives us 17x, 3x plus 14x, and 30 plus 4 is 34. So here in the end, x equals 2. Then we can use the second one. It really doesn't matter which one you use. I'll use the first one. Because I've used it once. I don't really care. I mean, it's both of them will still take you to the same place. Minus 2y equals 2. So that's going to give you 14 minus 2y equals 2. Now, sometimes you can figure these out right away. I'm going to go down here for a second and show you something. 14 minus 12 equals 2. So I know that whatever's in here for this block right here has got to be 12. And so I know that y is 6 because 2 times 6 is 12. So, I can just go over here and just say y equals 6 without even having to do any more work. Okay. A math professor by the name of Samuel B. Gruden once said that the essence of mathematics is to make the complicated simple, not to make the simple complicated. Okay, so what that means is that, the math is meant to make things easier for us to do with it. The math shouldn't be the problem. It should be the solution to the problem. Okay. Now, we'll see all the steps when I roll back the PowerPoint for it. Okay. But you see how you can actually shorten some of these steps, by just understanding the math a little bit better. Okay, so I'm going to clean up my stuff. Then we're going to go here. Okay, so there we see the 14. And we're going to see them cross out the 4 y's, and there's going to be 17x. We'll divide both sides by 17 and come up with x equals 2. Then we're going to plug that into the first one. 7 times 2 is 14. Okay. Then from there, we'll subtract 14 from both sides. And that'll give us negative 2y equals negative 12. We'll divide both sides by negative 2, and then y equals 6. Okay. Now, once again, when we were here, this may not be for everybody, and that's fine. We knew that had to be, let me get here, which is the same thing. We knew that had to be 12. Okay. And basically, that's what they're working with here. We knew it had to be 12 because 14 minus 12 is 2. And so from there, we knew that 2 times 6 is 12. Okay, so here's another problem here. All right, so in this problem right here, we can choose to get rid of the x's or the y's. Okay, in this case, we're going to get rid of the x's by multiplying the top by 3 and the bottom by negative 2, so that we can come up with positive 6x and negative 6x. Okay, and so it's going to create these new equations here. So we go from here to here. And we do that by multiplying everything in here by 3. And everything in here by negative 2. Okay, now we can cancel out the x's and solve for the y's. So that means y equals 4. From here, we'll plug 4 in for y. And then that's going to give us 12. Okay, now we can come back here. And we can say, okay, 12 here. In order to get a positive 6, this has got to be a negative 6. Right like that. That'll equal 6. Okay, so we can see that. So x has to be negative 3. Okay, so 2 times negative 3 will give you negative 6. Okay, so we could do that to shorten it. Okay, once again, we can go ahead and expand it out and go through all the steps if we can't see what the answer is right away. And then we'll divide both sides by 2, and x still equals negative 3. Sometimes you can see it in the math what the answer actually is without going through all the steps. Okay, and that's fine. Sometimes you'll have to take all those steps to get there. Okay, the next method we'll look at is the substitution method. The substitution method works when one of the equations is written in slope-intercept form. And so that top equation, y equals 2x, is written in slope-intercept form. That's y equals mx plus b. In this case, b is 0. Okay, so as we're solving this problem, we're simply going to plug in the 2x for the y. That's why it's called a substitution method. Okay, now by substituting in the 2x for the y, we've basically eliminated one of the variables. Okay, so you can see that we have 3x plus 2 times 2x equals 21. So in this case, we just have a bunch of x variables, no y variables. So we're going to add them together. 3x plus 4x is going to be 7x. And then 7x equals 21. So we'll divide both sides by 7. And x will equal 3. Okay, we'll put that value in for x. We can put it into the first one because 2 times 3 is 6. And so y equals 6. Okay, so here's another problem. Once again, the top one is written in slope-intercept form. Okay, we can see that. So we just plug in the x minus 3 for y. And then we'll distribute. Combine the x's together, gives us 5x. Then from there, we can go ahead and add 9 to both sides. Okay, and then we can divide 5 from both sides. Okay, and so as we're working through this problem, we can see that, that answer is going to be 5 because 25 minus 9 is 16. Okay, and so in this case, x equals 5. Okay, and so we can just plug the value for x into the first equation, and 5 minus 3 is 2. Okay, here's another one for us. The second problem is written in slope-intercept form. So that means we can take out the y here and plug in the negative 2x plus 2. We'll distribute 2 times the negative 2x plus 2. And from there, we'll combine the x's to come up with negative 3x plus 4. We'll subtract 4 from both sides. And that'll give us negative 3x equals 6. Then we'll divide both sides by negative 3. X equals negative 2. We can then take that negative 2 and plug it back into the slope-intercept equation. And then we'll just do the math to solve for y. So y equals 6. Here's a problem that deals with systems of linear equations. If the sum of the two integers is 10 and their difference is 2, find the integers. Okay, so the first one's going to be x plus y equals 10. And then the second one is the difference, going to be x minus y equals 2. From here, we can use the addition method to eliminate the y's. Add the x's together, add the 10 and the 2 together. X will equal 6. From there, we can plug 6 back in for one of the x values and solve for y. Y will equal 4. Okay, at this point, we're going to take a 5-minute break. And then once the break is over with, we're going to come back and get to the word problems. Okay, guys, let's get started on the word problems. Okay, word problems are something that we see every day in the real world. In fact, that's what the math problems look like in the real world. They're actually word problems. Here's an example of a word problem here. As I was going to St. Eve's, I met a man with 7 wives. Each wife had 7 sacks. Each sack had 7 cats. Each cat had 7 kittens. Kittens, cats, sacks, wives. How many were going to St. Eve's? Okay, in this case, only the man was going to St. Eve's. The 7 wives, the other man, the wife with the 7 sacks, the 7 cats, and the 7 kittens were all met along the way. They weren't going. Okay, so this is an indication of how word problems work. Okay, word problems is about, word recognition, understanding what the important words or keywords are in a word problem, and utilizing those to perform the math. Word problems are clearly about details. If one detail is left out or misunderstood, the whole problem will be incorrect. Okay, so when we're dealing with word problems, there's some buzzwords that we have to recognize or keywords to let us know whether we're going to add, subtract, multiply, and divide. Here's a few for addition, and here's a few for subtraction. Here's some words we use to recognize for multiplication, and then some words that we use for division. It's a good idea to familiarize yourself with the keywords, because most of the times understanding what operations to perform is the critical thing when we're working with word problems. Here's some words for equal, and here's some words for inequalities. Okay, the ones at the bottom, at most and at least, are going to be the most important, because at most means less than. People get tripped up on that one a lot when they see that word most and at most. They assume that that's greater than, because most and greater kind of go together, and least and less kind of go together. So, that one, when they see at least, it's hard for people to resonate with at least and greater than or equal to. Other words that we use to translate in word problems are sum, difference, product, and quotient. These are the answers to the various operations. Okay. When we're working with word problems, we need to denote commutative property, because with the commutative property, what that's basically saying is that the order doesn't matter, that we can put the numbers in any order. We don't have to be careful about the order when we're working with word problems, when we're dealing with math and multiplication. It can be 5 plus n, or it could be n plus 5. The order doesn't matter. Same with multiplication, the order doesn't matter. It can be 5n or n5. With subtraction, the order does matter. 5 less than n has to be n minus 5. Okay, if you put 5 minus n, the answer is going to be wrong. It has to be n minus 5, with 5 less than n. The quotient of 5 in a number has to be 5 divided by a number. It cannot be n divided by 5, because division and subtraction are not commutative. So we have to be very careful with the order of the numbers when we're dealing with division and subtraction. Okay, here's a problem. The sum of 6 and a number. Okay, because this is addition, it doesn't matter what order we put them in. We're still going to come up with the right answer. So whether we say 6 plus n or n plus 6, we're still right. Now this one we have to be careful. The difference of 6 and a number, because subtraction is not commutative. So the difference of 6 and a number has to be 6 minus n. The difference of a number and 6 is going to be n minus 6. Okay, with the subtraction, the commutative property is important. Okay, because subtraction is not commutative, therefore order does matter in this problem. The product of 6 and 9, we can put them in either order, it doesn't matter. The quotient of 6 and a number the order has to be the correct order, which is going to be 6 divided by n. Okay, here we have 7 decreased by a number. Take away a number from 7. 7 less than a number. Less than, subtract it from, and take away from the numbers are in a different order than they're read. Okay, so here's the other one, 7 subtracted from. So notice the order is changed. Okay, so here's a word problem. Lily baked 12 cookies yesterday. She baked n cookies a day using n, writing the expression for the total number of cookies. The word total means to add, so it's going to be an addition problem. Ted has a bookcase with D shelves. There are 13 books on each shelf. And what that means is 13 books per shelf. Okay, so that means it's going to be a multiplication problem because per means to multiply. And it says find the total. Now, the reason why we end up using the word total again, because multiplication is a shortcut for addition. Okay, so we could go, we could just really go and add up each of the 13 books for each shelf if we knew how many shelves there were. There are X chairs in a classroom. 25 of them are occupied. Using X, write an expression for the number of chairs that are not occupied. Okay, so that's going to be X minus 25. Okay, and as we're looking here, we see other words to let us know how to translate the words to math symbols. In this case, the word difference, subtract. Sum means to add. Notice how we got 3 times their sum, twice their product. Okay, and then the quotient of their sums and their product. Okay, so the product of 4 and the sum of a number and 3. The first thing we need to do is just go ahead and figure out what's going on here. That's multiplication. So that's multiplication right there. And that's addition. And the next thing we need to know is that there are locators. The and tells us where the multiplication symbol goes there and where the addition symbol goes here. Okay, so the and is a locator. It tells us what a multiplication, so that's 4 times, open parenthesis, n plus 3, close parenthesis. The addition goes in between the number and 3. The and locates it for us. The difference of a number and 5 is subtracted from 6. Okay. Now, here we got, this is subtract. And then this one means to subtract. So we got 2 subtraction signs here. The first subtraction sign goes right here because the and tells us to. This subtracted from, okay, remember we said less than, subtracted from, and take away from. The order changes. So that means all of this right here that's being subtracted, and that's being subtracted from it. So this right here, the number and 5 is being subtracted from 6. So that means that the 6 is actually going to be first, minus n minus 5, like that. Okay, and why? Because that word subtracted from means that the order switched. So these two things switched around. Okay, that went up front, and then that went to the back side because of that word subtracted from. Okay, here's another one. 3 more than a number. 3 more than 5 times an unknown number is equal to 23. Okay, let me clean this up for a second. Okay, so we got 5 times an unknown number right here. The word more than means to add. Okay. That word means equal. Is and equal, they mean the same thing. And then so we got 23 here. Okay, so this is a breakdown on it. Now we could get away with saying 3 plus 5n, or we could say 5n plus 3 equals 23. So we can get away with either one. Okay, the correct way of writing it is 5n plus 3 equals 23. So that's the correct way of writing it. Okay, you'll end up subtracting 3 from both sides and come up with 5n equals 20. The answer n is going to equal 4 anyway. And then we'll divide 5 from both sides, and it'll equal 4. Okay. But if we had said 3 plus 5n, we still would be okay because addition is commutative. And so understand that one little rule makes us okay with, not having to worry about the order so much. Okay. When 4 times an unknown number is subtracted from 31, the result is unknown. Okay, so here we've got 4 times an unknown number, so that's one number. Subtracted from means to subtract, and then that's going to be 31. Now these two are going to switch places. That's going to come here, and then that's going to come up here. Now the reason why is because that word subtracted from. And then the result is unknown. So that's going to be that. And the result is going to be an equal sign there. Okay, so that's the way it's going to work. In the end, it's going to be 31 minus 4 times, we'll say 4x, and then that'll equal x. Because the numbers are known like that. Okay, so that's the way we'll do it. 31 minus 4x equals x. Okay. It's best to circle the numbers and underline the operations, the keywords that let you know what operations to perform. The operations are the ones that's going to be the problem. Okay, the other stuff is not a problem. Okay, so the sum of a number and 6 is 11. This is going to be n plus 6 equals 11. 2 less than a number is equal to 6. That will be x minus 2 is equal to 6. The difference of n and 11 is 6. That's going to be n minus 11 is 6. Or x, it doesn't matter either way. Okay, and then the same here. A number divided by 4 is 9, or we can say the quotient of a number and 4 is equal to 9. Either way, that's going to be a number that's going to be x divided by 4, or x over 4 equals 9. Okay, inequalities. Okay, this word right here means, you can see that, less than. Okay, and then of course sum goes right here because of that and. That means plus. A number is x or n, and 2 here, and then 4 here, and then that's of course less than. And then here's another one. And 5 times the number is at most. Not most means less than or equal to, and we're working on this one. Okay, that's going to be that. Then we've got 5 here. Then we've got X here. At most means less than or equal to. And then of course we got a 10 here. Okay, so that ends up being 5n is less than or equal to 10. Okay, knowing the words that let you know whether you add, subtract, multiply, divide, and the comparison symbols are equal to, less than, greater than, less than, equal to, greater, equal to, makes a world of difference. It makes the word problem so much easier when you're understanding, what words mean to add and what words mean to subtract and what words mean to divide and then what words mean to multiply. Okay, so translating sentences into equations. Okay, so 27 is the product with Jenny's age and 23. So the word product means answer to a multiplication problem. So Jenny's age is going to be 3j equals 27. When we look at this word problem here, that means equal. Okay, and then 27. Jenny's age is one number, and 3 is another one. And then product means multiply. Okay, but the product's going to be located right here where the and is. So that's going to be J3 or 3J. Now remember we said multiplication is commutative. Okay, so you could say J3 or 3J. And they tell you to use variable J on this one. So 3J equals 27. Okay. And then they want you to write an inequality for that one. So x is greater than or equal to 13. It's written just as it's the inequality is going to be written just as the sentence is written. Okay, so here's some strategies for solving word problems. Most important thing is to read carefully, and you're reading for understanding, which means that you should be reading to figure out, what words tell you to perform which operations. Okay, you can draw pictures. I like to draw pictures and then sometimes to set up tables too. And the reason why you're drawing pictures and to set up tables is not necessarily for understanding, but to summarize the data. Okay, sometimes you have so much information till you need to summarize it. And so pictures and tables will do that for you. Okay, see that word read again? You got to really read. Okay, you can make estimates. And that's a good idea. An estimate just kind of lets you know what the answer could be. Okay, so if you come up with an answer and there's nowhere near what it could be, then you know you made a mistake somewhere. You need to figure out what the variables are, what the unknowns are, because you're going to need to put in x's and y's and n's for those unknowns. You can almost use whatever you want to use for an unknown. Like sometimes when I'm working with apples and oranges, I use an A and a B. Write as many equations as you need to. It doesn't hurt you to write more. I've seen problems that could be solved in one equation, and I ended up writing 2 or 3 equations, but I still got the same answer. So you got to always solve the equation using the math. Check your answer to make sure it makes sense, and then reread the question. Notice that word read is in there 3 times, twice at the beginning and then once at the end. Okay, so here's a problem right here. Here's a sales tax problem. Our dress costs $75.33 after the tax is added. If the tax is 8%, how much is the dress? Okay, so now remember I said I like to use tables at the beginning. So this is what I'll do. I'll say, okay, the cost. Okay, this is a table. Plus the tax equals the after-tax costs. And you could say, you don't have to call it after-tax cost. That's just what I'm labeling it as. You could say the real price or whatever you want to call it, but it's after tax. After tax. I left out the word tax. Cost. Okay, so that's the way I'm going to set it up. Okay, now, that's the way I set it up. Now, the thing I got to figure out is what information they've given me. They've given me the after-tax amount, and they've given me the tax rate. That's all they've given me. What I don't know is I don't know the cost of the dress. So, because they're asking me how much is the dress right here. That's the question. How much is the dress? Okay, so I'm going to call the dress D. Okay, so the cost, so I don't know what D is. I don't know what the cost of the dress is. But I do know that the cost of the dress, to find the taxes, has to be 8%. So 8% of D would give me the taxes. Okay. And I know the after cost is $75.33. Like that. Okay, so now at this point I got all my information. So from here I have to use algebra to finish this problem out. So I've got D plus 0.08 D equals 75.33. Then from here I get to add up the 1D and the 0.08D, which gives me 1.08D equals 75.33. Then I get to divide 1.08 from both sides to figure out how much the dress costs. So when I divide that, and I'm going to use my calculator on it so I don't have to really write out all that. Well, I said I was going to bring my other calculator, but I didn't do it. Okay, so let me make sure this clear out. 75.33 divide 1.08. So at that point, I now know the dress costs $69.75. Okay, so that's what the dress costs, $69.75. Okay, so that okay, I got a question. Oh, the 1.08, sure. Okay, the 1.08 came from right here. Okay, the D is really 1D. Okay, and so if I take $1 and I add 8 cents to it, that gives me $1.08. So that's where that's the language of algebra. You know, even though we're saying D, that's really 1D. Okay, so that's where that 1.08 is coming from. You're taking $1 and you're adding 8 cents to it. You know, and I know sometimes that's unfair because a lot of times math teachers, you know, we put that D and we assume that everybody knows that that's 1D. And that's because we're so used to speaking the language to, you know, that's just the way it is for us. But that's a good question. Okay. Now you guys see how I use the table to solve this problem? Okay, tables are real important. You know, the table helped me to solve this problem. Almost all of these problems can be set up the same way. Okay, the cost plus the tax equals the after-tax cost. And then you just fill in the information you know, and then you kind of, the stuff that you don't know becomes variables. Okay, so let's see where we're at now. And then that's the breakdown there, and so there you go. Okay, so here's another problem where it says the taxable amount of sales is $70 and the rate is 6%. find the sales tax amount. Okay, and so it's going to be the same way. You're going to take the $70, multiply the 6%. That'll give you $4.20 for the taxes. Okay, now this problem right here is going to be similar to the type of graph you're going to need in your project too. Okay, where your break-even point, come back. Where did it go? Okay, here we go. Where your break-even point can be found here. The break-even point is where they're both the same. Okay, and so if that's your break-even point, everything up here is your profit. And everything below here is your cost. Not your cost, but your loss. Okay. This blue line is going to be revenue. Revenue of sales. Okay. Not on this graph, but on the graph that you'll be doing. And then this will be your expenses. Because these are both costs on this one. Okay, so that'd be your cost. Okay, so when your cost is above your revenue, you have a loss. And when your revenue is above your cost, you have a profit. Okay, so I'm going to clear this up in a second, but I just wanted to show you guys this because a lot of people are going to be asking about, how to create these graphs later on. Okay, and the graph is just as simple as this one right here. Okay, you start off with revenue. You have your revenue that goes up based upon how much you make per hour or per month, and then your cost. And at some point, hopefully your revenue graph passes your cost graph. At the point they cross each other is the profit. At the point it goes beyond the cost or your expense, then that's your profit. Okay, so I'm going to take that away because I just want to use that one to help us understand for the project too. Okay, so in this one they're going to start asking some plans. Which plan costs the most at 50 minutes? Okay, and so we can look at 50 minutes for plan A and 50 minutes for plan B. And so we can see plan B costs 12, plan A costs 4. So plan A costs the least. How much less? 12 minus 4 is $8. It says, for what number of long distance minutes do the two plans cost the same? That's your break-even point. They cost the same right there. So it's $20. If the cost spent on long distance is more than this amount, which plan costs more? Okay, so right there, once we go above the break-even point, where they cost the same, we can see plan A actually costs more than B. Okay, so we have more word problems to deal with. These are dealing with like unit rates and how to figure out what unit rates are. This one says how many dollars did she pay per pound of salt? Okay, let's look at this. One buzzword is pay, so that's the dollar. And then pound is here. And then that per tells you how that gets divided. So the pay is $5 divided by 10 pounds. Okay, and that's 50 cents. Okay, so we can see that. Now here is the same thing again. Okay, she receives, okay, so how many pounds of salt does she receive? So there's that word pounds again. And then here's the word per right here. And then the dollars are here. So now that gets reversed. 10 divided by 5, which ends up being 2. So, and then the question said how many pounds of salt? So that's 2 pounds. Okay, So that were how many pounds, because that's what the question was asking. The first one was 50 cent because how many dollars. Okay. Okay, this type of problem is going to be a DTR problem. DTR problems is distance equals time times rate. Okay, and so in this problem, we got to figure out what's her rate of speed. Okay, now unit rates and rate of speed are all the same. Okay, then we'll see another one that talks about conversion rates. Okay, so rates are really big, interest rates, tax rate, they're all constant, they stay the same. So we're trying to figure out what this person's constant speed rate is. It's going to be 40 miles per hour because 320 divided by 8 means that she covered 40 miles each hour. So that's where we get 40 miles per hour from. So it's going to be 40 miles per hour. And then we can take that 40 miles per hour and multiply it by 24 hours to figure out what she can do in 24 hours. So 40 miles times 24 would tell us that she can cover 960 miles. Okay, and that 40 miles per hour is an average. Okay, it's much like if you can pick up 7 buckets in 30 minutes, then how many buckets can you pick up in an hour and a half? Well, if you can only do 7 in 30 minutes, then you can do 7 another 30 minutes and 7 another 30 minutes. So an hour and a half is like 30 minutes. So, you can only do 21 buckets unless you speed up or something. I get some extra help. Okay, so here's ratios of proportions. 3 to 4 can be represented as 3/4, 3 to 4, 3 over 4 like that. Lisa spends $50 at a grocery store. Of this amount, she spent $12 on fruit. What percentage of the total did she spend on fruit? That's going to be 12 out of 50. Now we can divide 12 by 50, and then that will give us 0.24. Move the decimal 2 places to the right, 24%. Okay, so that's a ratio. Now, a ratio is different than a proportion. A proportion involves two ratios, and we're saying that they're equal to each other. Okay, that they're equivalent fractions. So in order to solve proportions, we have to cross multiply. So we say 2 times x, and then 7 times 8. And then that gives us 2x equals 56. And then we divide both sides by 2, and that gives us x equals 28. Now here's a problem right here. Emma earns $97 in 4 days. How many days will it take her to earn $485? So obviously what they're wanting us to do is take that tool of what we know about ratios and proportions and use it to solve this problem. Okay, so the way it works is this way right here. Okay, so they want to know how many days. So what I'm going to do is I'm going to say, okay, you can put the days on the top or the dollars on the top. Sometimes I just feel better putting the dollars on the top because I can say 97 divided by 4, that's almost about 25 bucks. I just feel better seeing it that way. So I'm going to say, okay, I'm going to have my dollars on the top and my days on the bottom. Now with proportions, because they're equal to each other, I'm saying that I've got dollars on the top here and days on the bottom as well. Okay, so now I'm going to fill in all the information I need to have them be equal to each other. And that makes sense because dollars can't be equal to days. Dollars can be equal to dollars and days can be equal to days. So, okay, so in the first one it says Emma earned $97. So I'm going to put 97. And then that's going to be over 4 because the days were 4. So that's what I'm comparing, $97 to the 4 days she worked. On the second one, it says how many days. So since I don't know how many days, that's going to be D. I mean, if they knew the days, they wouldn't be asking. And so then she earns 485. Like that. Okay, so now this gets cross multiplied, 97D And then that's going to be 4 times 485. So we have 4 times 485. That gives us 1,940. I'm going to check that again because I'm using my phone. And sometimes the phone, I learned, does not always work out the way I want it to. Yep, so that works. So now we got to divide 97 for both sides. Okay, and then when we do that, D equals 20. Okay, so we use proportions to solve this problem. Okay, the setup is just as long as you set it up right, you're gonna be fine. Okay, so let's see. Latrell's saying, for the last problem, could you have figured the answer out by 2 over 7 equals 8x by dividing the 2 into the 8 and then using the difference to multiply the 7 to come up with 28. So you want to divide the 2 by 8 and then multiply. I don't know if you would want to do that. Okay, let's go back to that problem. I mean, there's another way of doing it. I don't know if that's a healthy way of doing it or not. Uh, Another way of doing it is to treat them like fractions. Why did it disappear? Okay. Okay, so another way you could have did it if you got 2 7s here. And you've got, I mean, it would have worked out, but I'm just going to leave the bottom part blank. So I'm going to say 2 times 4 equals 8, because they are equivalent fractions. And 4 times 7 equals 28. Okay, so that's a more healthier way of doing it. I mean, yeah, so I mean, it'll work for you, but the thing is you're trying to back into the equivalent fractions by doing that. Okay, like say for instance, if you had 1/5 and you wanted to find an equivalent fraction for 1/5, you could multiply the top by 7 and the bottom by 7 to come up with 7 over 35. Okay. And you use the math rule to do that. What you did is you found an equivalent fraction, using, our rule for equivalent fractions. Anytime you multiply the top and bottom of a fraction by the same number, or divide the top and bottom of a fraction by the same number, you have an equivalent fraction. So, I mean, basically that's what you ended up doing, but you backed into it. I would prefer, if you were going to do that, if you're looking for equivalent fractions, you would, just go that route at it, 2 times 4 and then 7 times 4. Okay, but the most effective way of doing it is to cross multiply. Okay, even finding it this way, I don't recommend it. It's not the most efficient way of doing it. The most efficient way is to cross multiply, because sometimes you'll be swimming in decimals and that can create problems for you. Okay, so here's another problem. Now this problem, we're going to have shadows and feet. I think that'd probably be the best way of doing it. Okay, and so you can see the feet were put on the top. What is the height of the tree is unknown, so the feet are unknown. Uh, we cross multiply here again, uh, and that gives us 4x equals 168. Divide both sides by 4. X equals 4. Not 4, but x equals 42. Okay, here's a DTR problem here. Um, in this problem, we've got a distance problem. When we're working with these types of problems, sometimes we're going to use pictures, like in this case. And so we've got 45x plus 60x. And then that's going to be added together to equal 210x. Okay, the entire thing is 210. And so part of it is 45 miles at x. Now the 45 times x in this case is going to equal the distance, whatever that rate is. So if it was like, let's say if it was like 3 hours, then that would be 45 times 3. And then that would give us 135 miles. Because you'd multiply the 45 times 3 to get the miles. And then the same thing with the 60. And so those two things added together, 45 times 60, going to equal 105 miles per hour. And then we divide both sides by 105. And then x will equal 2 hours. Okay, so it takes 2 hours in order for us to get 210 miles apart. All right, here's another motion problem. An airplane takes 8 hours to travel a distance of 672 kilometers against the wind. The return takes 7 hours with the wind. Find the rate of the plane in still air, and what is the rate of the wind? All right, so we've got two different equations at work here. This is one equation right here. Okay, and we've got two different speeds. We got the speed of the plane and the speed of the wind. Okay, but the hours are going to be consistent. So we got 8 hours. Right, I'm putting that over here. 8 hours. And then we've got the rate of the plane, which is going to be x. And it's against the wind, so we're going to take the wind away. And then that's going to equal the total distance of 6272. And then we've got 7 hours. And then we still got the rate of the plane, but it's with the wind, so we got to add the wind to it. And then that's going to equal 6,272 here. Okay, the distance is the same for both. Okay, the rate of the plane, how fast the plane is going, and how fast the wind is going is going to be the same for both. Okay, the only difference is the time. And the time should be different because if you're going with the wind, your rate is going to be faster. Okay, so for that 7 hours, you should be able to get there in 7 hours with a faster rate because you got the speeds, you got the plane speed, and you got the wind speed added together. And so that's going to give you a faster rate. Okay, now to solve this problem, okay, I can simplify this down by dividing both of these by 8 and then dividing that by 8. But I'm just trying to get it simpler. I'm going to divide that by 7, and I'm going to divide that by 7. Okay, of course, that'll cancel out. That'll cancel out. And then I'll be just left with x minus y, okay, equals, and then let me see if it'll shake out to be a whole number. That's what I'm hoping for. 6,272 divided by 8. 6,272 divided by 8. It's going to be 784. And then x plus y divided by 7. That's going to be 896. Okay, so that's your problem right there. Okay, so from here we can use the addition method. That's where you cancel out the y's here and here. The elimination method, cancel these out, and you're left with 2x here. Add the x's together. And then you add the other side together, the 784 and the 896. That gives you 1680. Then you divide both sides by 2. I think that's 840. I think that's 840, but I'm going to do it anyway. It's 840. Okay. So we can take one of these equations, x plus y equals 896. And put the 840 into it for x. X is the rate of the plane. Plus y equals 896. I can see that's 56 from here, so I'm not gonna prolong the steps. So y equals 56 because 56 plus 840 is 896. Okay, so there we go. What was the rate of the plane? 840. What was the rate of the wind? 56. Okay. And once again, that took understanding that you had two rates, that you had the speed. And we're talking rate, we're talking about speed rate. We had the speed of the plane and we had the speed of the wind. Okay, so that's how that problem's done. Okay, now it is a DTR problem, so we had the time times the rate equals the distance. And in this problem, the time was clearly, I'll put that there, the time was 8 and 7. The rate was the wind and the plane, and then the distance was the 6,272 kilometers. So we started off with a t here. T times r equals the distance. Okay, now that formula can be used a lot of different ways because this is what we call DTR, which is the distance equals the time and rate. So it can be manipulated like most problems can be. So let's okay, and so we see it all fold out. Okay, see here how we got the rate here. Okay, now against the wind means minus the wind. With the wind means add the wind. And then of course that's 8. So that's these right here, time times rate. These two things together give you this right here. Okay, and so that's how they come up right here to be the distance. Okay, and so you got that distance equals 6,272. And the same there. And then, of course, we kind of see how we broke it down by simplifying it down. We simply use the addition method on it. And there we go. All right, that concludes the lecture component. Okay, we got about 13 minutes left for questions and answers. Does anybody have any questions that they want to ask about the Alex or the project? Yes, the project. Okay, the graphing, what's the question? Well, Erica, you should have a graph in your video to show your profit. Okay, so that's what the graph's going to be used for. Okay, let me see if I can move all this over. And we'll go to it. Sketchpad is what I'm looking for. Okay. Okay. What I'm gonna do is give you an example, show you how I would do it. Okay. Let's say, for instance, I'm gonna let's say I'm going to charge $400. Now, yeah, I say $350 an hour for people to use my studio. Okay. So what I'm gonna do is I'm gonna set up a graph like this. Okay. And then it's not going to have a zero value. It's not going to have any value below there. So I'm going to say this right here is going to be my 300, my revenue line. So that's going to be Y equals 350X. And of course, the X is my time because I'm saying I'm making $350 an hour. Okay, so that's my revenue line right there. Now notice it doesn't go all the way through. Okay, because the least amount of hours I can have is 0. So I'm not going to have anything negative in this case. Now, let's say I got to have some cost. So I say, well, it's going to cost me 200. I'm saying it's going to cost me 200. Let's say, yeah, $200 an hour. Plus I got some fixed costs of maybe say 1,500 a month. Okay. So I'm gonna put 15 about right here. 15. Let's say I'm gonna have some fixed costs about. I'll say about 1,200. Okay. So I'm gonna have some fixed costs of about 1,200. So so I'm gonna have 1,200 in fixed costs, and instead of saying, let's say $80 an hour. Okay, so I can get that right. Okay. So I'm gonna start about here for my cost line. And it's going to run probably about like this right here, like that. Okay, now that cost line is going to be Y equals $80 an hour X, so that's 80 times X, plus my fixed cost of 120. So that means if I don't do at the very start of the month, I'm guaranteed to have $1,200 worth of cost. Okay, well here's my break-even point, much like that telephone one we was using. That's break-even right there. So I can tell people my break-even is right there. I don't know how many hours that's gonna be right there. But I can figure it out, and I don't know what the dollar amount will be right there. I can figure it out too. The way I can figure it out is I can just make the two equal each other. I can just say, okay, 350x equals 80x plus 120 plus 1,200. And then that'll tell me at how many hours I'll break even, because X equals the hours. Okay, so if I subtract 80 from both sides, then I have 270. X equals 1200. Okay, and then I'm going to divide both sides by 270. So 1200 divided by 270. And so that's going to be X equals, it's going to be 4.4. Like that. Okay, so that's roughly around 4 hours and some change. I'll break even. Okay, or I could say that's 4 sessions. Instead of charging an hour, I could charge 350 a session, and then I can say in 4.4 sessions I'm gonna break even. Okay, so I could do it that way instead of X equal, and then I'll just say X equals a session instead of using time. So at that point, I'm gonna break even. So let's say if I rent it out for I rent it out 5 times, I'm gonna be making profit. Okay, so that's my sales pitch. Anything over 5, anytime I get 5 customers a month, I'm gonna be making profit. Now, what is the odds of me doing that? If I'm advertising and doing everything I'm supposed to be doing, the odds of me doing that are pretty good. So this is a cash business. It's gonna be lucrative. I'm gonna be making a lot of money once I get 4 customers in. Anything above 4 customers, I'm ready to start making money. Okay, and so that's why they want you to use the graph. Okay, but yeah, this way you'll have to create your own revenue and cost equations. Okay, so it'll be based upon your revenue and your costs. Okay, any other questions? Um, Teaching books, instruction to guide me on how to do the problems. Alex has some instructions in it on how to do problems. I mean, that's pretty much it. You can go to Google, not Google, but you can go to you can use YouTube as well. And then of course there's the go-to trainings. Yeah, and then there's also Khan Academy. And then there's purplemath.com as well. Okay, but I mean, it's not going to provide you like with all of the concepts. You have to kind of go in there and give them the concept that you're working on, and then they'll provide you with information on it. because our class is college math with algebra, so it means it's got algebra, but it's got other fields of math as well. It's got probability, statistics in it. It's got arithmetic in it, so it's got different fields of math in it. It's got financial math. Yeah, but a good place to go is like the go-to trainings. You can ask questions in there. But I know sometimes they don't happen fast enough for you because it's not real time. You can always go to YouTube or Khan Academy. Khan Academy has some good videos. And I think that's khanacademy.org. I don't think it's .com because it's not a it's not commercial. It's nonprofit. Okay, folks. It is 3:59. We have 1 minute left. Then that is going to wrap up our class. Okay, it is 4 o'clock. So that's going to conclude our class. We have other go-to trainings coming up later. I want to say later today. Let's see. You're welcome. Let's see when the next one's coming up. Shut that down for a second. Don't save that. Okay, we have one coming up tonight at 9 o'clock with Professor Lindsay. So if you need additional information, she's going to be discussing the project part 2. Okay, so if you need more information on the project, Professor Lindsay will be here at 9 o'clock tonight. All right, folks, thanks for a great go-to training meeting. I will archive this go-to training meeting by tomorrow, and I will make it available for you guys sometimes tomorrow. All right, so you guys have a great one and take care of yourself.